Hello everyone, myself Rajesh MKSV, Senior Faculty Maths, Narayana Group. So today I am here to discuss January 30 afternoon session paper. So this paper, what the questions which we have collected is completely memory based questions. So there might be few differences between the original question and the question which I am going to discuss. But the idea is to understand the difficulty level and what type of models are being asked in the mains papers. So let us get into the paper now. So the first question, which is based on probability. Bag A contains 7 white balls and 3 red balls. Bag B contains 3 white balls and 2 red balls. A ball is chosen randomly and found to be red, then find the probability that it is taken from bag A. So first let us write the total probability of getting a red ball. So it can be from bag A or bag B. The probability of getting a red ball from bag A will be 3 by 10. 3 red balls, total balls will be 10. Getting a red ball from bag B will be 2 by 5. Now, you have to write 3 by 10 here because he is asking probability that it is taken from bag A. Since it is Bayes theorem, we are writing total probability here, and whatever condition is mentioned that we are taking into numerator. So this will be 3 by 3 plus 4, which is 3 by 7. So the answer will be option 3, which is a direct question from probability. Next question, which is based on vectors. So he is asking mod of b bar cross a bar minus b bar whole square. So if I take this as one vector and this as one vector, it is like mod of x bar minus y bar whole square. So which will be mod b bar cross a bar whole square plus mod b square minus 2 times of b bar cross a bar dot b bar. So 4 plus 4, and this will be 0 because box of BAB, which is 0. So this is 8, and this is also a direct question from vectors, option 2. Let us go to the next question. So which is based on domain of the functions. So first, if I am taking ln of this thing, so whatever is there inside the ln, that must be greater than 0. So which means I'll get 2x plus 3 divided by 4x square minus x minus 3 greater than 0. And along with this, I have to write domain of this cos inverse, which is minus 1 less than or equal to 2x plus 1 by x plus 2 less than or equal to 1. So if I solve this side, it will be 2x plus 3. If I factorize the denominator, I'll get it as 4x plus 3 into x minus 1 greater than 0. So if I simplify this using wavy curve, I'll get it as minus 3 by 2, minus 3 by 4 and 1. So plus minus plus minus. We want positive. So x belongs to minus 3 by 2 to minus 3 by 4. Open everywhere because it is strictly greater than 0. Union 1 to infinity. Now this side of inequality if I solve, it will be 2x plus 1 by x plus 2 plus 1 greater than or equal to 0, which will be 3x plus 3 divided by x plus 2 greater than or equal to 0. So I'll get x belongs to minus infinity to minus 1 union, sorry, minus infinity to minus 2 union minus 1 to infinity. Minus 2 I have to take open, minus 1 I can take closed. And if I solve this side of inequality, I'll get along with this 2x plus 1 by x plus 2 minus 1 less than or equal to 0, which will be x minus 1 by x plus 2 less than or equal to 0. So and x belongs to minus 2 to 1 closed. So if I am taking intersection of these two things, I'll get x belongs to minus 1 to 1. Now if I take intersection between these two things, I'll get it as minus 1 to minus 3 by 4. So minus 3 by 4 open, minus 1 closed. So he has given it is alpha to beta, alpha equal to minus 1, beta equal to minus 3 by 4. So 5 alpha minus 4 beta is equal to minus 5 plus 3, which will be minus 2. So it will be option 1. Okay. So it is also simple domain based question. Just you have to calculate it. Next question. f of x is equal to x by 1 plus x power 4 whole power 1 by 4, and g of x is equal to f of x. So if I am just considering first f of x, which will be f of x by 1 plus f of x whole power 4 whole power 1 by 4. Again, if I replace f of x with x by 1 plus x power 4 whole power 1 by 4, 1 plus x by 1 plus x power 4 whole power 1 by 4 whole power 4 whole power 1 by 4. So this will be simplified to x by 1 plus x power 4 whole power 1 by 4 divided by, so 1 by 4 4 will cancel, and it will be 1 plus 2x power 4 whole power 1 by 4 divided by 1 plus x power 4 whole power 1 by 4. So these two things will cancel. I am getting it as x by 1 plus 2x power 4 whole power 1 by 4. Which means from here I can understand the pattern that f of x will be x by 1 plus 3x power 4 whole power 1 by 4. And 4 times if I am taking, I'll get it as x by 1 plus 4x power 4 whole power 1 by 4. Now if I substitute here g of x, we got it as this. So 0 to square root of 2 times of root 5 x square into g of x will be x cube divided by 1 plus 4x power 4 whole power 1 by 4. Now let us substitute 1 plus 4x power 4 is equal to t power 4. So this will give you x cube dx is equal to t cube by 4 dt. And when x is equal to 0, t power 4 is 1, which means t is 1. When x is equal to square root of 2 root 5, t power 4 is 81, which means t is 3. So it will be 1 to 3 t power 3 by 4 into t dt. So which is, if I integrate, I'll get t cube by 12 from 1 to 3. So 3 power 3 minus 1 power 3 divided by 12. So 26 by 12, which is 13 by 6, which is option 2. So again, a calculation based question, you have to just simplify it. Let us go to the next question. The first term of a GP is A and third term is B. So if I am taking two GPs, first GP and second GP, in first GP, third term B is equal to A R1 square. If I assume R1 is a common ratio of the first GP, then here B is fifth term. So it will be A times of R2 power 4. So if I equate these two things, I'll get R1 equal to plus or minus R2 square. Now 11th term of first GP, so 11th term T11 will be equal to AR1 power 10. Now if I substitute R1 as plus or minus R2 square, I'll get R2 power 20, which is nothing but AR2 power 21 minus 1. So this is T20 first term in second GP. So 11th term of first GP is common to 21st term of second GP, which is option 3. A simple sequence series based question, GP based question. Next, so two equations are given and he is asking number of common roots between these two equations. So if I take the second equation first, z cube plus 2z square plus 2z plus 1 equal to 0. Now from observation I can say z equal to minus 1 is a root, because minus 1 plus 2 minus 2 plus 1, which is 0. So if I divide with minus 1, then what I'll get 1, 2, 2, 1, 0, 1, minus 1, 1, minus 1, 1, minus 1, 0, which means this can be written as z plus 1 into z square plus z plus 1 equal to 0. So which means z equal to minus 1 or omega square, where omega and omega square are the cube roots of the unity. So if you check, z equal to minus 1 is not a root for the first equation. If I am taking the first equation, that is z power 1985 plus z power 100 plus 1 equal to 0, z equal to minus 1 is not satisfying this. If I substitute z equal to omega, then it will be omega power 1985 plus omega power 100 plus 1. So I can write this as omega power 3, uh, 3 6 18 661 into omega square, and this can be written as omega power 3 whole power 33 into omega plus 1. So this is anyway 1, so omega square, and this is also omega cube 1, omega plus 1. which is 0, which means z equal to omega is a root of that equation. Now if omega is a root, then omega square will also be, because the roots will be conjugate. If the coefficients are real, roots will exist in conjugates, so z equal to omega square is also a root. So the number of common roots between these two things will be 2. There are 2 common roots between these two equations. So let's go to the next question. So if x square minus y square plus 2hxy plus 2gx plus 2fy plus c is a locus of points such that it is equidistant from the lines, then the value of h plus g plus f plus c. So indirectly he is asking us to find the angle bisectors, pair of angle bisectors between these two lines. So we know x plus 2y minus 8 divided by root 5 is equal to plus or minus 2x plus y plus 7 divided by root 5. So this is how you find angle bisector equations. So which means one equation will be x plus 2y minus 8 is equal to 2x plus y plus 7, and the other equation will be x plus 2y minus 8 is equal to minus of 2x plus y plus 7. So from here I'll get x minus y minus 15 equal to 0, and 3x plus 3y minus 1 equal to 0. So if I multiply these two things, x minus 5 minus 15 into 3x plus 3y minus 1 equal to 0. So if I multiply 3x square minus 3y square, xy coefficient will cancel because minus 3xy plus 3xy will get cancelled. If you see the x coefficient, minus 45x minus x, which will be minus 46x. Y coefficient, um, which will be minus 45y plus y, which will be minus 44y plus 15 is equal to 0. So x square minus y square minus 46 by 3x minus 44 by 3y plus 5 equal to 0. Now if you compare this with the given equation, what we are getting here, h is equal to 0, g is equal to minus 22 by 3 minus 23 by 3 minus 23 by 3, and f is equal to minus 22 by 3, and c is equal to 5. Now he is asking h plus g plus f plus c, which is equal to 0 minus 23 by 3 minus 22 by 3 plus 5, which is minus 45 by 3 plus 5 minus 15 plus 5 minus 10. So the answer should be minus 10. The answer is not there here. It means they might have noted down the wrong options. So the exact answer will be minus 10, which is a simple angle bisector based questions. Let's go to the next question. So a matrix is given and a trigonometric equation is given. He's asking trace. So if I take this entire thing is equal to k, which means I'll get x plus y plus z is equal to k times of sine theta plus sine theta plus 2 pi by 3 plus sine theta plus 4 pi by 3. So sine theta plus sine 120 plus theta plus sine 240 plus theta, which is 0 by transformations. If you apply transformations and if you simplify, you will get that sum to be 0. So which implies trace of the matrix A is equal to 0, which means statement 1 is true. If you go to the statement 2, trace of adjoint A. So trace of adjoint of A can be written as trace of adjoint A. Property will be det A into A. So det A is xyz, and into trace of A is again x plus y plus z. So this will be xyz into x plus y plus z, which is again 0 because x plus y plus z is 0. So which means statement 2, here it must be trace of adjoint A equal to 0 must be given. So both the statements are true. So which means option 1. So let us go to the next question. So Sn is equal to 3 plus 7 plus 11 plus and so on. So this is an AP common difference 4. So I can write Sn is equal to n by 2 into 2a, that is 6, plus n minus 1 into d, that is 4. So n by 2 into 6 minus 4, 2 plus 4n So which will be n into 2n plus 1. Now he is asking 6 by n into n plus 1 sigma k equal to 1 to n sk. So which means sigma k into 2k plus 1 from k equal to 1 to n he is asking. So this can be written as 2 times of sigma k square plus sigma k, which is 2 times of n into n plus 1 into 2n plus 1 by 6 plus n into n plus 1 by 2. So this will be equal to, if I am taking n into n plus 1 by 6 common, so I'll get 2 times of 2n plus 1 plus 3. So which will be n into n plus 1 by 6, and this will be 4n plus 5. Now if you multiply this with 6 times of 1 by n into n plus 1, this will cancel. So I'll get 40 less than 4n plus 5 less than 45, which implies n lies between 35 by 4 to 10. So the only integer between 35 by 2 and 10 is 9, because 35 by 4 is 8 point something. So 9 is the only integer between them. Next question. So in a paper there are 3 sections A, B, C, which has 8, 6 and 6 questions each. A student have to attempt 15 questions such that they have to attempt at least 4 questions out of each section. So let us take the cases. Let us take section A, section B, section C, and section A contains a maximum of 8 questions and a maximum of 6 questions, and C maximum of 6 questions. Now let us write the cases in a particular order. Like I'll start with least number of questions from A, that is 4 questions from A. Then next least number questions from B, that is I can take, if I'm taking 4, then 4 plus 4 will be 8. I need 7 questions which are not there in C, which means I have to take 5. 4 plus 4 9. I require 6 more. So 4 5 6 is one case. Next I can take 4, the next least number is 6, and here it will be 5, and that's it. I cannot take 7. So next, if I am taking 4, if I am going the case of 5, if I am taking the case of 5, uh, here I can take next least number will be 5, and 5 5 5 I can take. If I am taking 5 here, I can take 6 here, I can take 4 here, and I can take 4 here and 6 here. There is no other possibilities, because if I am taking, I cannot take 7 from B or C, so which means these are the only possibilities with 5. Then if I am taking 6 here, if I take 4 here, I have to take 5 here. If I am taking 5 here, I have to take 4 here. If I am taking 6, then I cannot take 3 from the C, because I should take at least 4. The next possibility is 7. 7 if I am taking here, minimum 4 I have to take here, and obviously 4 from here. Then I cannot take 5, 7, 5, because 12 plus 3, I should take minimum 3. So I can safely say that these are the only possibilities. So if I write out of 8 questions from A, I have to choose 4, 8C4 into, this will be 6C5 into, this will be 6C6. So here it will be 8C4 into 6C6 into 6C5. Here 8C5 into 6C5 into 6C5. So this will be 8C5 into 6C6 into 6C4. 8C5 into 6C4 into 6C6. 8C6 into 6C4 into 6C5. 8C6 into 6C5 into 6C4, and 8C7 into 6C4 into 6C4. Now if you simplify these things and if you add all these things, you have to add all these things because there are different possibilities. So after simplification, you will get this sum as 11376, which is option 2. So here you have to list out the cases. If you are not listed in the case, then if you do it directly, then you might count repetitions. So always these type of things, it is better to list out the cases and then you have to add these things. So let us go to the next question. F of x is x minus 2 whole square, x minus 3 whole cube, and x belongs to 1 to 4 if m and m denotes the maximum and minimum value respectively. So these type of questions, first you have to find the critical points, and then you have to find the functional values at the critical points, and you have to find the functional values at end points. So among these values, whichever is maximum, that will be the maximum. Among these values, whichever is minimum, that will be the minimum. So if I am differentiating f of x, I'll get it as 2 times of x minus 2 into x minus 3 whole cube plus 3 times of x minus 2 whole square into x minus 3 whole square. So this, if I am taking x minus 2 into x minus 3 whole square common, so the things that will be left out is 2 times of x minus 3 plus 3 times of x minus 2, which will be x minus 2 into x minus 3 whole square. This will be 2x plus 3x, which will be 5x minus 6 minus 6 minus 12, which means f dash of x equal to 0 implies x equal to 2, x equal to 3, x equal to 12 by 5. So if I take f of 2, so the value of f of 2 will be, if you calculate f of 2 here, it will be 0, and f of 3 is also 0, and then f of 12 by 5, if you calculate, you will get it as 4 by 25 into minus 27 by 125. And if you calculate the functional values at endpoints, as I said earlier, f of 1 is minus 8 and f of 4 is 4. So if you observe among these values, the maximum value is f of 4. So maximum is f of 4, that is 4, and the minimum is f of 1, which means it is occurring at endpoints. F of 1 is equal to minus 8. So which means you can say in this interval it is increasing function. In the interval 1 to 4, no, I cannot say, but if you observe the critical point, it is not increasing function. If you observe the critical points and the end points, so you are getting maximum minimum values at end points only. So he is asking, this is capital M, this is small m. So m minus m will be equal to 4 minus of minus 8, which is equal to 12. Okay. So this is not an increasing or decreasing function, just the maximum and minimum values are occurring at end points. The global maximum and global minimum in the given interval 1 to 4. So the answer will be 12. So let us go to the next question. A bar is given, mod b square is given, angle between a bar and b bar is given, and a bar dot b bar is given. So if you are taking a bar dot b bar equal to 3, I can write mod a square mod b square into cos square pi by 4 is equal to 9. So mod a square into mod b square is 6. This is 1 by 2 equal to 9. So 2 3s, 3 3s. So mod a square is equal to 3. Now he is asking alpha square plus beta square. So if I am taking mod a square equal to 3 means 1 plus alpha square plus beta square equal to 3. So this implies alpha square plus beta square equal to 2. And mod of a bar cross b bar whole square will be mod a square mod b square into sine square pi by 4. Mod a square is 3, mod b square is 6. This is 1 by 2. So 9. So finally alpha square plus beta square into mod a bar b bar square is equal to 2 into 9, which is 18. The answer is 18. A simple vectors question. Now let us go to the next question. If y minus 2 whole square is equal to x minus 1 and x minus 2y plus 4 equal to 0, then find the area bounded by the curves between the coordinate axis in the first quadrant. So let us draw the graph properly first. So let us take this is equal to y equal to 2, y equal to 2 line, and this is x equal to 1 line. So the parabola will be like this. And if you observe this x minus 2y plus 4 equal to 0, if you find the points of intersection with the curve, that will be y minus 2 whole square is equal to x minus 1. I can replace it with 2y minus 4. So 2y minus 5. So this will be y square minus 4y plus 4 equal to 2y minus 5. This is y square minus 6y plus 9 equal to 0, which implies y minus 3 whole square equal to 0. Which means it's a perfect square, means it is touching the parabola. It's a tangent. It is a tangent to the parabola. And it is also passing through. When I put x equal to 0, y is equal to 2. So the line will be something like this. It is a tangent like this. So between the coordinate axis in the first quadrant means I'll get this area plus this area. And this point is y equal to 3. This is y equal to 2. So I'll write this required area as integral. So between these two things, y is equal to 0 to y equal to 2, right curve minus left curve. This is right curve and this is the left curve, that is x equal to 0, and this is x is equal to y minus 2 whole square plus 1, plus from 2 to 3, that is this part of area, right curve is again y minus 2 whole square plus 1, and the left curve will be this straight line, that is x is equal to 2y minus 4, this is into dy, this into dy. So we are using right curve minus left curve concept. Now if you integrate and if you substitute, you'll get the answer to be 5.5. Okay, so you have to just simplify this calculation. 0 to 2 y minus 2 whole square plus 1 dy, 2 to 3 y minus 2 whole square plus 1 minus 2y minus 4 dy. So you have to just simplify the calculation. So this type of problems, if you use right curve minus left curve, it will be easy to simplify. Next question, based on trigonometry. So given 3 sin a plus b equal to 4 times of sin a minus b, and if tan a equal to k tan b, then value of k is. So I'll write sin a plus b divided by sin a minus b is equal to 4 by 3. If I apply componendo and dividendo, then what I'll get? Sin a plus b plus sin a minus b divided by sin a plus b minus sin a minus b equal to 4 plus 3 divided by 4 minus 3. So which will be 2 sin a cos b divided by 2 cos a sin b is equal to 7 by 1. Which means from here I can say tan a is equal to 7 times of tan b. Which means k is equal to 7. 7 is the answer. Okay. Next question. X into x square plus 3 mod x plus 5 times of mod x minus 1 plus 6 times of mod x minus 2 equal to 0, then find the number of solutions of the given equation. So obviously x equal to 0 is one root when I equal it to 0. So this is one solution. Then the remaining part, x square plus 3 times of mod x plus 5 times of mod x minus 1 plus 6 times of mod x minus 2 is equal to 0. Now, in order to remove these modulus, we have to take cases. So, first case we'll take it as x less than 0. When x is less than 0, I'll get this as x square minus 3x minus 5 times of x minus 1 minus 6 times of x minus 2 equal to 0. Now, if you are simplifying this, x square minus 3x minus 5x minus 6x, which will be minus 14x, and then the next thing will be plus 5 plus 12, which will be 17 equal to 0. So we have taken x less than 0, but here we are getting roots as negative because sum of the roots is positive, product of the roots is positive. So both the roots are positive, which means no solution here. No solution in x less than 0. The next case will take it as 0 less than x less than 1. Then what I will get? X square, this will be plus 3x, this will be minus 5 times of x minus, because mod x minus will be 1 minus x, that is minus of x minus 1 for x less than 1, and this is also minus of x minus 2 equal to 0. Now if you are simplifying this, you are getting it as x square 3x minus 5x minus 2x minus 6, this will be minus 8x, and then this is again 17 only. So if you observe here the roots, discriminant, if you are finding, discriminant is equal to b square 64 minus 68. So which means less than 0. Here also no solution. Then if I am taking next case, that is 1 less than x less than 2. So what I'll get here, x square plus 3x plus 5x minus 5 minus 6x plus 12. So this will be x square plus 8x minus 6x will be 2x, and this will be minus 5 plus 12, which will be 7. So here also discriminant is less than 0, which means no solution. The next case is x greater than 2. So when I am taking x greater than 2, I'll get x square plus 3x plus 5x minus 5 plus 6x minus 12 equal to 0, which is x square 14x uh, minus 5 and minus 12, which will be minus 17 equal to 0. Now here if you observe, if you find the roots, you will get both the roots greater than 2, but both the roots less than 2, but we have taken the case x greater than 2. Okay, if you find the roots and if you approximate them, or if you use location of roots, you will get both the roots as less than 2, but with the case we have taken is x greater than 2. So here also no solution, which means the only solution we got is x equal to 0. So only one solution is there for it. Number of solutions will be 1. So let us go to the next question. A set R is equal to set of 1, 2, 3, 4 is given, then find the number of symmetric relations which are not reflexive relation. So if I am taking four things, let us assume a matrix 4 by 4 matrix. This will be 1 1, this will be 1 2, 1 3, 1 4, similarly 2 1, 2 2, 3 3, 4 4. So if you want symmetric relations, just symmetric relations, then I can take these diagonal elements or I may not take the diagonal elements, right? So which means I'll get 2 power 4 cases into, now if I am taking this element, I must take this element. So selecting this or not selecting this will be two ways. Selecting this or not selecting this will be two ways. So no need to select these things again, because when upper triangle elements are selected or not selected, then corresponding elements will be selected or not selected. If you are selecting 1 2, then you have to select 2 1. If you are not selecting 1 2, then no need to select 2 1. So how many elements will be there here? 1 2 3 4 5 6. So it will be 2 power 6. So this will be total number of symmetric relations. So from here I'll subtract relations which are both symmetric and reflexive. So reflexive means I have to select all these diagonal elements, because 1 1 2 2 3 3 4 4 everything must be there. So they are selected, selecting them will be one way. Now this will be 2 power 6 ways, selecting this or not selecting, selecting this or not selecting, 2 into 2 into 2, 2 power 6 ways, right? And the corresponding lower triangle elements will be selected or not selected. 2 power 6 if I am taking common, 2 power 4 minus 1, 2 power 6 is 64, 2 power 4 16, this is 15. So if you simplify this, 15 6 900 plus 15 4 60, which will be 960. So 960 is the answer. Okay, so for symmetric relations, you may select or you may not select diagonal elements, and if you are selecting any one element from the upper triangle, automatically the corresponding element will be fixed, selected or not selected, depending on the corresponding element selected or not selected. And from there you have to remove the reflexive relations. So reflexive relations means you have to select all the diagonal elements, that is one way, and now you are finding symmetric relations, 2 into 2 into 2, 2 power 6. So number of symmetric relations minus number of symmetric relations which are reflexive will give you number of symmetric relations which are not reflexive, that is 960. Next question. F of x is a e power 2x plus b e power x plus cx. F of 0 is minus 1. F dash of ln 2 equal to 4. So here if you observe in the question, you are having three unknowns and they have given three conditions. So it is very easy that you use three conditions, you will get three equations and you can solve three unknowns. So first thing is f of 0 equal to minus 1 implies you will get a plus b equal to minus 1, one equation. Then f dash of ln 2 equal to 4. So which implies first f dash of x is equal to 2 times of a e power 2x plus b e power x plus c. So f dash of ln 2 is equal to 2a into e power 2 ln 2 plus b into e power ln 2 plus c. So 2a times of e power ln 4, which will be 4 into 4, plus this will be b into 2 plus c. So 8a plus 2b plus c is equal to 4. This is one condition. Next, integral 0 to ln 4 f of x minus cx dx is equal to 39 by 2. So this implies f of x minus cx will be a e power 2x plus b e power x integral 0 to ln 4. So if I integrate, this is equal to 39 by 2. So this implies if I integrate this, a e power 2x by 2 plus b e power x from 0 to ln 4 equal to 39 by 2. So this will be 2 ln 4 e power ln 8. So 8a by 2 4a plus this will be 4b is equal to 39 by 2. So a e power x by 2, okay, minus this 0 is also there. So this will be e power ln 8. So this will be 4a. If I substitute here, it will be e power ln 4 4b minus 0 if I am substituting a by 2 minus b equal to 39 by 2. So this will be 4 to 8 minus 7a by 2 plus 3b equal to 39 by 2. So, so three equations, three unknowns. You can easily solve these things, right? So when I am substituting ln 4, ln 8, 4a, yes, everything is fine. So here a plus b equal to minus 1 is one equation, and from these things we are getting one more equation, that is a equal to x means ln 4. Here a into e power 2 times of ln 4. So 4 square, this is 16 actually. Yes, I made a mistake here. So this will be 16 by 2, 8a. So then this will be 16 minus a, 15a by 2. So if I cancel 3, this will be 5a by 2 plus b equal to 13 by 2. So 5a plus 2b equal to 13. So three equations, three unknowns. If you solve these things, you are getting a value as 5, b value as minus 6, and c value as minus 24. He is asking a plus b plus c. So which will be 5 minus 30, and modulus of that, which will be 25. 25 is the answer. Three equations, three unknowns. Easy question. So overall, whatever questions we got here from memory based, all are easy questions. Maybe difficult questions they might not have remembered it, but the questions which you have seen is they are direct questions only. Little bit of calculation is involved in few questions. Otherwise, conceptually they are very easy questions. Thank you everyone.